The world of mobile communication has evolved significantly over the years, and one of the most remarkable advancements has been the transition from 3G to 4G. This presentation will explore how speed increased considerably during this shift, highlighting key technological advancements and performance improvements. Faster networks have revolutionized the way we communicate, browse the internet, stream content, and use real-time applications. 3G limitations. While 3G was a major step forward in mobile communications, it had several limitations. It was designed primarily for basic mobile internet services but struggled with the growing demands of modern applications. The speeds were relatively slow, often around 1 megabit per second, making activities such as high-definition video streaming, real-time gaming, and large file downloads difficult. Browsing the web on 3G often felt sluggish, and video calls suffered from lag and poor quality. As users started consuming more data-intensive content, it became clear that a faster and more efficient network was needed. 4G introduction. To address these growing demands, 4G was introduced as a next-generation mobile network. Unlike 3G, which had limitations in handling high-speed data, 4G was designed to support real-time applications, high-definition video streaming, and ultra-fast downloads. This improvement was achieved through advanced network architecture and more efficient use of available spectrum. With 4G, users could enjoy a broadband-like experience on their mobile devices, making video calls, online gaming, and media consumption seamless. Speed improvement. One of the most significant changes from 3G to 4G was the drastic increase in speed. While 3G networks provided speeds of around 1 megabit per second in real-world conditions, 4G LTE advanced networks could achieve speeds exceeding 100 megabits per second. This meant that downloading a high-definition movie, which previously took several hours on 3G, could now be done in just a few minutes on 4G. Faster speeds also meant smoother video streaming, quicker web browsing, and an overall enhanced user experience. From circuit switch to all-IP network, a fundamental shift in network architecture played a key role in 4G's improved performance. 3G networks relied on a mix of circuit switch technology for voice calls and packet switch technology for data. This dual approach created inefficiencies, especially when handling multimedia content. 4G, on the other hand, adopted an all-IP architecture, meaning both voice and data were transmitted over the internet using packet switching. This transition resulted in lower latency, improved call quality, and better overall network efficiency. Higher bandwidth. Another major advantage of 4G was its ability to utilize wider bandwidths. In 3G networks, each channel was limited to 5 MHz, restricting the amount of data that could be transmitted at any given time. 4G expanded this to 20 MHz per channel, allowing more data to be transmitted simultaneously. This increase in bandwidth directly contributed to higher speeds and improved network performance, especially in areas with a high density of users. Efficient data encoding. To further enhance data transmission efficiency, 4G introduced more advanced modulation techniques. In 3G networks, QPSK, or quadrature phase shift keying, was commonly used, encoding 2 bits per symbol. With 4G, higher-order modulation schemes such as 64 QAM and 256 QAM were introduced, allowing 6 to 8 bits to be transmitted per symbol. This increase in bits per symbol meant that more information could be packed into each signal, significantly boosting data speeds and overall network capacity. MIMO, more antennas, more speed. Another key innovation in 4G was the use of MIMO, or multiple input multiple output technology. Traditional 3G networks relied on a single input, single output antenna configuration, limiting data transfer rates. 4G introduced massive MIMO, utilizing multiple antennas at both the transmitter and receiver. Configurations such as 4x4 and even 8x8 MIMO enabled better signal reception, higher data rates, and improved coverage, particularly in congested urban areas. This advancement allowed networks to handle multiple data streams simultaneously, resulting in faster and more reliable connections. OFDM versus CDMA. The method of multiplexing signals also changed significantly from 3G to 4G. 3G networks used CDMA, or code division multiple access, which allowed multiple users to share the same frequency band by assigning each user a unique code. While this approach was effective, it led to interference and reduced spectral efficiency. 4G replaced CDMA with OFDM, or orthogonal frequency division multiplexing. OFDM divides the available frequency band into multiple smaller subcarriers, each carrying a portion of the data. This method minimizes interference, improves spectral efficiency, and enhances overall network performance. Latency and speed gains. Latency, or the delay between sending and receiving data, was significantly improved in 4G networks. In 3G, latency typically ranged from 100 to 500 milliseconds, making real-time applications such as gaming and video calls challenging. 4G reduced latency to just 30 to 50 milliseconds, making interactions much more responsive. Additionally, real-world 4G speeds ranged from 50 to 100 megabits per second, a substantial improvement over the 1 megabit per second typical of 3G networks. These advancements enabled smoother video conferencing, faster cloud computing, and an overall more efficient mobile experience. 4G changed user experience. The transition from 3G to 4G had a direct impact on everyday activities. For instance, downloading a 1 GB file on 3G could take anywhere from 15 to 20 minutes, whereas on 4G, the same download could be completed in just 2 to 5 minutes. Video streaming saw a massive improvement, as 3G often struggled with buffering at 480p resolution, while 4G enabled smooth playback in Full HD and even 4K. Online gaming, which requires low latency, benefited greatly from 4G's faster response times, allowing for real-time interactions without lag. Key takeaways: 3G versus 4G. To summarize, the shift from 3G to 4G brought several key improvements. Bandwidth increased from 5 to 20 MHz, enabling higher data transfer rates. Modulation techniques evolved from QPSK to more efficient 256 QAM, packing more data into each transmission. MIMO technology allowed multiple antennas to work together, dramatically increasing speed and reliability. CDMA was replaced by OFDM, improving spectral efficiency and reducing interference. Finally, the transition to an all-IP architecture reduced latency, making 4G networks more responsive and capable of handling modern Internet applications.